Okay, so again, here, right? What we're doing, remember, is we want to calculate z-scores, okay? Excuse me. That's what we want to calculate, okay? You know, I put the formula down here. We're assuming now that the weights of the data values here, which are weights of certain dog breed, of a certain dog breed, the weights, they're approximately normally distributed. The mean is 62 pounds, and the standard deviation is 6 pounds, okay? That's what we're assuming. And let's say one of the dogs weighs 55 pounds. We want to know what the z-score is, and if the dog's weight is unusual or not. Remember, for the weight to be unusual, you know, if you went back to the empirical rule, where is that? Here. You know, a z-score that's below -3 or above 3 is unlikely, so unusual. So essentially, you're just seeing if the z-score is between 3 and -3. That's how you answer this part of the question. Okay, so x here is 55 pounds. We want to convert this to a z-score, so we use the formula. We have 55 minus 62 over 6, which is -7 over 6, which is about -1.17 if you do that in a calculator. So that's the dog's z-score. It's negative, you know, that's expected because it weighs less than the mean. Its weight is less than the mean, that's better to say. And notice that it's within 3 standard deviations. In other words, the z-score is greater than -3, but less than 3, and less than 3, I mean. So this dog's weight is not unusual. You know, it's not unusual. For the second one, here we have a dog that weighs 85 pounds. Now the question is, what's the dog's z-score? And is this dog's weight unusual? Same idea. We find the z-score, which is 85 minus 62. I make a mistake. Must have made a mistake in the calculation. That should be 85. Oh, 85. Okay. This should be 85. My mistake. The calculation's right, but this should be 85. Sorry about that. So this is 85, okay? The z-score then is 85 minus 62 divided by 6, okay? And that is 23 over 6, which turns out to be about 3.83. You know, it's a little less than 4. So that's the z-score. Now notice this is greater than 3. I mean, it's less than 4, but it's still greater than 3. So this dog's weight is unusual. The dog's weight of 85 pounds. Okay? All right. But now in number 3, we want to find the z-scores that correspond. We want to find, the dog's weights, the data values that correspond to z-scores of 3 and -3. Okay, so here we want to do that. So we want to convert this to, so that's what we want to do here. Okay. Okay, so for 3, we have 3 is x minus 62 over 6, okay? Right? We want to find x. So again, this is what I did. I did x minus 62 over 6 equals 3. That's what I did. Now we want to solve for this x, right? We want to solve for it. Okay. So from here, we're going to get 6. So again, we want to get x. So let's get the 6 out of there. We're going to multiply both sides by 6. That's going to help us. And why is that going to help us? That's going to cancel this with this. You know, they cancel out. That's why we have x minus 62 on the left side of the equal sign. And on the right side, we get 18. So from here, right, we want to get x. Let's add 62 to both sides. We get x equals 80. So 80 has a z-score of 3. Okay, 80 has a z-score of 3. For negative 3, it's the same idea. The only real difference is that instead of 3 here, you're going to have minus 3. Okay, so x minus 62 over 6 equals negative 3. So what do? Multiply both sides by 6, right? Okay, so then we, just like before, we multiply by 6, right? And what is that going to do? That eliminates these two. We get x minus 62 on the left. We have negative 18 on the right. Then we add 62 because we want x to be all alone. We get 44. So 44 corresponds to negative 3, a z-score of negative 3. So this tells us that if a dog's weight for this breed, if they're between 44 and 80, that's not unusual. Less than 44 or greater than 80 is unusual. And this also tells us by the empirical rule that 99% of all the data values are between these two. But again, this is how we can use z-scores. Well, part of the way we can use z-scores to determine what percentage of data values are less than a number, greater than a number, and between two numbers. Okay, good. All right. Are there any questions on this? Because now we have to use Desmos. I showed this last time. Guess not. Okay. All right. What I thought I showed last time was how to graph the normal distribution in Desmos, although well, anyway, let me do it now. Okay, let me just get Desmos. So again, you want to get graphing calculator. So let me go to Desmos. Okay, so again, we're here. Let me do it this way. Let me, here we go. Now you go to Desmos, right? I'm already logged in. I mean, you don't have to you don't have to make an account. It's free though. So go to Math Tools, Graphing Calculator. So what you want to do is this. The little keyboard, let me see if everyone can see this. Good. The little keyboard on the bottom left here, you click that, then this will come up. Go to Functions, go to DIST for distribution. You could draw things like a dot plot, a box plot, histogram, okay? You could draw those. What we want is normal dist, okay? Normal distribution. These are actually other distributions that statisticians study. We're not looking at those though. We're just focusing on normal. Click there. And now you want to type in the mean, then the comma, then the standard deviation that you want. If you don't type anything, it's going to think that you want the standard normal distribution. Let me click to get rid of that. You might have to zoom in a bit. So you can do zoom in like this, like so. But you can type really anything you want. You can type 0, comma, 4. That makes it, the standard deviation is 4 and mean is 0. If I type 0 and 0.1, so this is 0.1, not 1. Let me do it this way. There we go. Here you can see the standard deviation is pretty small. So, you could draw a normal distribution that way. This cumulative probability, the CDF thing, this we'll get to shortly. This is actually, well, we'll get to that. I don't want to get into it now. Okay. But for instance, so if we had, let's say, let's say we took the mean to be, see, my notes I had 30, the mean is 34. Why did I choose such a big number? I don't know. But let me click and drag with the mouse. You can click and drag to get to 34, or this little wrench here, graph settings. See, you have x-axis. You can modify this. So you can go, say, I don't know, 30, and then you could do 40. See, then we're at 34. I don't know why I chose the mean to be so high, but that's okay, I guess. But anyway, we can graph different things here. So on the next slide in my notes, what we actually have is the mean 34 and a standard deviation of a half. See, that's what you get. You can always zoom in, as you can see. Click and drag with the mouse. You have to. Okay. Next, we had with the standard deviation, I made 1. See? I mean, this is probably what we saw last time. I graphed a bunch of these, and we saw that what happens when the standard deviation gets bigger, the graph gets flatter, and the smaller it is, the graph, the peak gets higher because the data is more clustered around the mean. And then we have 4. See, now it's pretty flat. So we have those. You know, so you can graph those, and I mean, if you have a graphing calculator, you can graph them, but in Desmos, you can graph them also, which is nice for free. Okay, let me get back to the notes. Here it comes. There it is. Okay, so let's get back to that. I put the screenshots in here showing you how to get to this. So, you know, you have that in your notes, which is nice. Same thing over here. Okay. And these are the 3 graphs. I mean, I made the colors different so you can tell which is which. See? So these are just graphs of this. Okay. You know, so this is over here, the one in red. This is the one in blue. This is the one in green. Okay. All right. This one I was going to have everyone try. Okay. Actually, yeah, you know what? Let me have, well, yeah, let's have everyone try that quickly. So, yeah, let's just go, yeah, so let's everyone try this now. Let me stop the recording. Just take like a minute. You're just basically graphing something. So then we'll do it together. So it'll take like a minute or 2. Let me just stop.